This video explains how to set up the FR robot environment in ROS 2. FAIRINO_hardware is an API interface developed for FR robots based on ROS 2, designed to make the FR SDK easier to use for beginners. This video explains how to configure the FAIRINO_hardware and FAIRINO MoveIt to plugin packages on Ubuntu 22.04 and establish communication with the robot. We recommend using this on Ubuntu 20.0 for LTS journey. After the system is installed, you will need to install ROS 2. For instructions on installing ROS 2, the official ROS_control, and the MoveIt to plugin package, please refer to the official website shown in the figure. After installation, configure the FR ROS to feature pack. First, open the FAIRINO online documentation. Click Open Platform for COBOL_ROS 2 to access the configuration manual. Online documentation displays the latest version by default. To view older versions, click the latest button on the page to switch between them. Click Downloads, Secondary Development, FAIRINO ROS to in the left-hand menu bar to access the ROS to feature package download page. Clicking this link will start the download automatically. You can also visit the official FAIRINO GitHub repository to select the version to download. After downloading, extract the compressed file to the ROS to workspace. Now that we're in the workspace, let's take a look at the structure of the FR robot ROS to development kit. FAIRINO description is a package containing the appearance and URDF files for the FR robot. FAIRINO_hardware is a hardware driver package. FAIRINO_MSGS is a function package. FOR data types used in FR robot data transmission. The remaining MoveIt to _config files are MoveIt to motion planning configuration files for various robot models, together with the API documentation and README. These files form a complete development environment for robot control. First, let's compile the code. Right-click to open the terminal, enter the compilation command, and wait for the compilation to finish. After compilation is complete, refresh the environment variables, connect the robot, and then enter the command to start the controller connection. Run cmd server. The terminal log shows that the connection to the robotic arm was successful, indicating that the ROS to command server has been created and successfully connected. Next, let's walk through the process of issuing commands. Open a new terminal and refresh the environment variables. Type RQT in the terminal once the command has finished executing, and a Qt GUI interface will appear. Select Plugins, Service Caller to bring up the following screen. Select the FAIRINO_command_service entry. Enter the command string in the expression field. Click Call to see the reply appear in the dialog box below. The program has strict requirements for the format of the input string. If the format does not match, an error will be reported. For specific command information, please refer to the API documentation, except for the get command, which returns a string. All other functions return values of type int. Generally, 0 indicates an error, and 1 indicates successful execution. If any other values occur, refer to the errors corresponding to the error codes defined in the XML APC SDK. Here, we'll use the mode switching command as an example. The robot is currently in manual mode. Input mode switching command and parameters. 1 for manual mode, 0 for automatic mode. Click the call button above to send the request. You will receive a response below, and the bot will switch to automatic mode. Next, we'll configure the FAIRINO MoveIt to plugin. This is a plugin that supports motion control and path planning for FR robots. The FAIRINO_hardware plugin serves as the middleware layer connecting MoveIt to the robot. Through the FAIRINO_hardware plugin, Move_group sends the motion plan to MoveIt_control, which then forwards it to ROS_control. ROS_control then uses the FAIRINO_hardware plugin to drive the actual robot motion. In addition, the FAIRINO_hardware plugin receives feedback data from the actual robot. This enables synchronization between the robot model in the reviz to simulation interface and the actual robot. Users can control the actual robot's movements through the ROS interface. Additionally, the FAIRINO_hardware plugin enables the robot to integrate with the ROS to control framework, making FR robots compatible with third-party packages based on ROS to control. First, configure the config file. Using the FR5 as an example, navigate to the directory shown in the video. Locate the file FAIRINO5_v6_robot.ROS to control.exe. Replace the plugin on the 9th line with FAIRINO hardware interface. Save the file and exit. Open the terminal and recompile the config package. This plugin receives real-time data on the actual robot joint states and feeds them back to move_group via ROS to control. Refresh the environment variables, then run the demo.launch.py file. Once the file is launched, because the FAIRINO_hardware plugin has been added, the ROS to interface will receive the actual robot joint states in real time and feed them back to move_group via ROS to control. Further, synchronize and control the pose of the simulated robot in the ROS to interface. You can control the actual robot's movement through the ROS to interface. Drag the blue sphere representing the robot's end effector in the ROS to interface to move the end effector to the target position, then drag the red, green, and blue rings on the end effector to change its orientation. Click the Planning and Execute button on the left to plan the motion path and control the robot's movement. The actual robot will also move in sync with the simulated robot. That concludes the guide on configuring the ROS to environment for the FR robot. Thank you for watching.